So I'm Kęstutis Valančius, representing the same university as my colleague, just a different faculty and department, building and energetics department. And it's a big pleasure for me to be in Georgia, the first time for me. I always wanted to visit it. And it's an honor to be the last presenter of the workshop again. But don't be afraid that my presentation will not last an hour, it will be shorter, so we will fit inside, I know. Okay, so my topic of the presentation is the aspects of energy efficiency of the building, but before this is built. And if the presentation before mine was about the good practice, nice example, so maybe with my presentation I want to show some maybe questions and problems what we meet in Lithuania, and I think not only in Lithuania, and even not to answer the questions but try to raise it and at least to think about that, how to solve it and so on. So if to look to the building cycle, building information model cycle, or even let's say building life cycle. So the analysis of building energy performance usually is made after the design is made of the building, or even in our case till now or something earlier, it was like you will start to think about building energy efficiency when building starts to live, and when you see how much it uses, and it uses a big amount of heat and electricity, and then you start to analyze why and so on and so on. So this is why this energy analysis, I can say, need to be moved to the question that in this case we start to analyze building energy performance, or before the renovation or something like that. But this thing need to be moved maybe to this phase before the design of the building, the architectural design. And if last year I was saying that it's good to move this thing to that place, so this year I can say it need to be moved, and even it's moved. Now we're doing that in Lithuania and I think in other countries. Because usually when we design the building, so we say we design the kilowatts but not kilowatt hours. It doesn't matter how many kilowatt hours the building will use, we design how much kilowatts, so on and so on. After that, the user of the building will pay for energy, and it's not the headache of the designer or owner or constructor or developer even. So, but now when we increasing the requirements in Lithuania from last year, and from next year we need to start to build higher performance, higher energy class buildings, and even this year I can see that a lot of architects and constructors they don't know what to do. How to design the A energy class building, because they need to design like that. Because anyway, it was just designed, and that's all. After that, energy certificator will say what kind of energy class you have. So I can say that we have an energy certification system in Lithuania, and it works quite quickly, but just from my point of view, it works a little bit not correct sometimes. So I will say why after that. So it means that energy certification, energy analysis, we need to move into the pre-design or design phase, and even, of course, it can be solved with building energy information modeling. And I can say that now the BIM era starts in Lithuania. Maybe some of you can say it's too late or something, because in university we just go into this now. For example, the students, they work with separate softwares, the architect with one, energy engineer to analyze the energy performance with another software, but need to be one model. And even as I imagine that architecture sitting and doing the design project, he needs to see somewhere in the corner kilowatt hours, electricity, cooling, heating, and to do the building then on that base energy efficient. Okay, so going to another thing, what is important, it's benchmarks. And this is a German example, not Lithuania. Because Germans have a lot of good examples, and we, in Lithuania, look to these examples. And why I'm showing German example, because in Lithuania we still don't have something like very exact energy benchmarks, energy numbers, what kind of energy use need to be in some different buildings, kind of buildings, and so on. We have someone, and this is very important because I said that certification system is not very correct, because some buildings are certificated to some energy class just because of the insulation layer and windows characteristic, but not by the kilowatt hours per square meter. It means that the glass building with the good windows, with good characteristics, can be certificated as very good energy class building, but because it's of the glass. But if you will look to the consumption by square meter for cooling, heating, you will see that it consumes a lot of energy. So this is the things that I think we need to improve in the thing about the certification. And while we need the benchmarks are important, that then you can see where is your building. Is this your building in? Okay. If your building is here, that's okay. It's okay, but you can find out that the building is somewhere here. Something wrong with the building. Or maybe just building is something wrong with just with electricity, just with heating. Because we usually divide heat and electricity. But of course, it could be divided benchmarks for heating, cooling, electricity for lighting, and so on and so on. It's an open question. And this benchmark, this cross, can be for A-class building, A-plus class building, B-class building, and you will find your building. So it means that even the architecture needs to find that your building fits into the benchmark, fits into this energy thing. Okay, so now I'm going a little bit more detail in some aspects that I think that architectures and constructors and everybody who designing the building need to keep in mind, that even starting from the shape of the building is important. That different shape of the building influences the energy use, energy performance, and maybe sometimes just by changing the shape of the building you can reach a better level, more correct by energy side. So it needs to be given in mind. Of course, it belongs on the local things, but first. Then, okay, now I go to the opaque envelopes. It means to the walls, roofs, not to the windows. So now what we have till next year, I can say anything. We build a building like we say it's a CB energy class. It means that the buildings which is built for 25 years, means after the independence, after the Soviet era, which is built for 25 years, it's about, it is like CB energy class. But now, from 16 year, by requirements, we need to build the buildings like A class. And in the requirements, it is written that the U value, heat transfer coefficient of the wall, for example, need to be for B class for residential building, 0.2. Now it's 0.12. And if I take A++ building, what by requirements we need to start to build from 221. So the U value of the wall need to be bigger than, okay, it's 2 times low. So I think that some colleagues from Georgia can remember, and even I know, so that on the Soviet buildings, U value is about 1. So even now we build the buildings with 5 times lower U value, it means 5 times more insulation. And after 5, 6 years we need to be 10 times more insulation, something like that. So if to look to this, it's okay. More insulation, less heating, and that's all. But we find the building renovation. About renovation means that we have a huge amount, still have a huge amount of Soviet era buildings which are very, very inefficient, especially heating side. And the process in some towns of Lithuania it goes quite quickly, but for example in Vilnius it goes slower. But anyway, you need to renovate these buildings or break it down. Something you need to do. So the thing is now that, for example, the cost of renovation of 1 square meter from, we say, FE energy class Soviet building, just the wall. So now the cost is about 100 euro per square meter, and even higher. And of course it's just a market. Then the renovation process started to increase. The prices for this process started to increase. And what's happening now that from another side the heat price even decreased now a little bit in Lithuania because we have alternative gas and other things. We started to use a lot of biomass in our central heating systems, and the price for heat is decreasing, the price for renovation increasing, and there is no payback. And the thing is that the system is that if you want to renovate your building, multi-flat building, okay, 100 flats, so at that moment, very important moment, more than 50% of owners of the building need to sign that. Okay, we will pay per month some money, and we will do it. And of course, when people see the investments, the millions of euros, then you can easily calculate that there is no economical payback. So another question, another way need to be found. And this is why in smaller towns the renovation process goes quickly, because the work prices and other things are lower. So it means this investment is low. And even it's easier in the smaller town to make some, okay, I will renovate not one building but the district. So it will be cheaper. So it's a problem in 25 years we still have the same buildings and we cannot change it. No payback. And even another thing is that I said about money payback, but even when we starting to look at another thing, more scientific thing, how much energy you put on the wall additional, the primal energy, because you need to produce the insulation and so on, to transport it, to make it. So you can find out that in a lot of cases, even I get somewhere another results, but in a lot of cases, especially for the CO2 carbon dioxide payback, means you use the CO2 for production and you put on the wall and then you save it because of the heating. So in a lot of times you see that, not in a lot of, but in some times, but if to put some another results, you will see that in a lot of cases you have very long payback. So what it means that the renovation has no any payback, money, energy, and CO2 sometimes. So it means that not renovation, insulation of the walls. So sometimes it could be done by reasonable rate and increasing the energy efficiency, not just insulating, because now you need to put something like 30 centimeters of insulation. Okay. Benchmarks. Yeah, I was lying a little bit to you that in Lithuania we don't have benchmarks. From last year we have new requirement, and here is some example of Yeah. For heating, some benchmarks for heating means that now you have some figure what need to be the energy performance, energy used for heating, for building, for multi-flat, for example, residential building, in this case, for different energy classes, okay, starting from B. Now we're building B classes. So, and of course, even these numbers are discussable. Yeah, we can discuss it a little bit more. Just I want to pay attention here to one difference. There is very big difference between B and A class. And after that, there is small differences between A plus and A plus plus. So I can say that these differences mainly is because of insulation. Increasing insulation and using the better characteristic for windows and doors. But this biggest difference is because of ventilation. Because with B class is mainly for residential buildings is natural ventilation. And if you calculate design, and it's necessary to design the A class buildings with mechanical ventilation and with recuperation system. There is another question I will touch it. So mainly this difference is not because of insulation, because of ventilation, natural, mechanical. But there are some numbers. Okay, my colleague said something about the building thermal mass. Yes, even the building thermal mass is very important, and it may be a little bit complicated graphic, but it means that as big a thermal mass, as more heat gains we can use in a building. Just showing like that. Just it's a question. The answer is that the lower, very low building mass, it doesn't accumulate the heat inside, and you cannot use it for. You cannot save it. It's such a thing. Next one. Yeah, and another thing is the system control is very important. Maybe I can stop here about coming back to renovation system, renovation situation. Quite a lot buildings in Lithuania is renovated from outside, insulated, nice building, but in some buildings, not a lot. In some buildings, it's nothing done inside. So it means that just the heating system works on a lower regime, but there is no any regulation addition. So it means anyway you can save if you put just thermostat on the radiators, you can save additional 30-40% of heat, because and even now in renovation, I do not speak about design, new building design, but renovation. It's necessary to put something like passive measures and active measures. It means that some control need to be done in the building, because of course without control you save energy, but it's not correct way. Okay. Another thing is when we have control, again the building thermal mass is important for control of the temperature and heat. It means that when we want to decrease the temperature to save energy, so then when we want to bring it back, the temperature, we have some additional boost heating regime we want to bring back, correct? So indeed, do not forget that things, and because people usually, they calculate this thing, the temperature goes like that, and the heat flow, heat power goes like that. And they say, I saved this, I'm saving this, is the real. No, it's not like that. Or if you will do like that, you will have temperature, not your next, not correct temperature. So it's another thing that if you want to, if you want to decrease the temperature, you can decrease the temperature. If you want to increase the temperature, you can increase the temperature. So it's another thing that if you want to to use your heating system with decreasing the temperature. So you need even to design the higher capacity equipment, and to keep in mind that you will need a higher capacity. So even not always it is good from economical side. And of course it's not allowed to decrease the temperature in winter more than 4 degrees or something like that, because it's impossible to bring it down the building. So even because of that, if we're using some intermittent heating, and now we always do like that. We have regulation and we just turning off the thermostat and turning out. And of course, it's another question for people. We need to explain for people what is a thermal whale, because they are using just like a whale to close and open usually. So it's another thing. We're always using this intermittent heating. So we need to keep in mind that sometimes we need to double our heat power in this case if we want to have a good comfort. It's another question. The comfort, energy efficiency is important. Okay. Yeah, so some examples, some modeling. The same building, and we have something like intermittent heating. We're pushing down the temperature at night, and when we need to bring it back per 2 hours, for example. Here is some little model for university. So it means that additional power in this case, we need something like 27%. Okay, we save this amount of per day in university. But you need to have this additional. If you don't have this additional good heating, the temperature will rise like that, and then the students come to the auditories, and it was earlier in our university. It was 16 degrees. Then on Monday you come to lectures, it is plus 16, because per weekend it was quite switch off the heating, and after that it bring it back. The heat power brings just back, but if you want to heat, there's some period even you need to heat more. And another interesting result is that the same building, but one we can say heavyweight building, bricks and so on and so on, and the same building is light building. So in this case, this building saves 2 times, more than 2 times less heat. If this building system, heating system works correct, like here is ideal case. If we look to the temperature, we push it down by 3 degrees and we bring it back by 3. So it means that on the building thermal mass belongs to this very much. And it's still open question. Not always, it's not easy to say that always a heavy building is better. No, but some cases show for something this kind. Okay, ventilation. Yeah, I said that. Now we have a question in the failure, because from next year every residential building need to be A-class building, it needs to have the recuperation system, mechanical recuperation system. But it's a big question, and we can discuss quite a lot that anyway the residential building has some infiltration, and if you have a big building, maybe you don't need the mechanical ventilation. But if to look very strictly to the airflows and energy consumption of the ventilation different systems. So some example shows very simple, just the euros per year per family. If you have 24 natural, it's obvious. Natural ventilation is 20 or it goes through the windows. Okay, we can regulate it. We have some drills, but filtration, ventilation. If we compare it with the same mechanical, so the difference is not very big. But anyway, it's cheaper. But of course, we have some additional electricity consumption. There is heat for air heating and for ventilation. But when we have mechanical ventilation, so of course you will not use it 24 hours per day. You can use it when you use your building. your residential building. So it's quite easy to calculate how many hours we spend at home and how many hours we are outside. So maybe 10 hours or 12 hours. So of course, if to look from energy side, the mechanical ventilation is much more effective than natural. But as I said, means in this case you need to keep in mind that your building is very tight. There is no any other air infiltration. It's quite impossible. And another thing is that I want to say, the prices, the heat price now in build is 7 cents and electricity 15, so it's calculated like that. But as I said, that the human factor is that even we think like that, I think that people will, okay, I have ventilation mechanical, I will switch on at first, switch on, yeah, it's nice working. But after some time, I think that the people will think like, anyway, it's electric equipment. If I switch on this electric, uses electricity, maybe to open the window costs nothing. So it's another thing. And of course, equipment and equipment. And yes, another thing is that, and we have a lot of buildings, and even our university buildings is like that, because the old Soviet systems are removed. The heating system, of course, it's reconstructed, at least the heat substation and some elements of heating system, but ventilation system, there is no ventilation system, quite, in some older buildings. And people think like that we can live without ventilation, because you cannot smell the CO2 and so on and so on, but it's wrong. It's wrong, and my opinion is that how we use thermometers inside the room, the same we need to use something like CO2 meters to see what kind of level of carbon dioxide we have. And after that, maybe the table, what kind of level need to be in the room. So you will see that usually it's we need ventilation. Okay. Now about the glazing. Very important things. Of course, one thing is very important, the window wall radius, area. Another thing is orientation. It's quite clear. Usually, orientation of the building, of course, belongs where our glazing area is orientated. And it's not so bad. Orientation in Lithuania is to the south, because in summer the sun goes up, and maybe the higher heat gains comes from in the evening from the west, not from the south, and in winter is better. But I want a little bit to say about heat transmittance coefficient. That when we design a new building and it has a lot of windows, so okay, the manufacturer, the constructor tries to put some as better windows as it can, and maybe expensive windows, and mainly what we do for office buildings, so we use something like sun heat reflective windows. Yes, it's good to use because you have a lot of windows, but you will have a lot of sun in summer. But what does it mean that what's good for summer is bad for winter? Or I can say what's good for Georgia, bad for Lithuania, because in winter we have very small number of sunny hours, and even this free heat from the sun is closed because of this window. So sometimes I'm joking that maybe we need to change windows like we change the tires of the car in Lithuania. Like half a year we drive with the winter tires, and half a year we drive with the summer tires. Because we change. Maybe we need to change the windows like that. Or maybe the better solution to make a rotating window and rotate it. In Soviet time it was the windows not like that, but it was rotating quite 180 degrees. Just we need to make a construction. So again we need to think about that. Okay, so I'm going to the another thing that here is some modeling of a different orientation, and it's a lot of data here. Different orientation, different window area, and it influences to the different system energy consumption. Yeah, so we can see how the orientation influences this building, office building. For example, east-west is quite the same. Even the south, as I said, for Lithuania, for south orientation, the consumption is low because the sun radiation usually is higher for that. But the most important thing is here is the percent, means the glazing area of the building. As higher area we have, as higher energy consumption we have in the building. As more windows, as more energy we need. And of course, we need additional cooling, when we need additional energy for ventilators, for pumps. If you have more cooling, more pumping, more ventilating, and so on and so on. Just on lighting, we can save some energy. That's all. So the conclusion can be that we need to build buildings with very small windows. Yeah. But another thing is that the hygiene requirements, the natural lighting requirement, even doesn't allow for these buildings to do smaller windows than even here the persons are left 87, something like 80%. So it means that you need, by hygiene requirements for lighting, you need to make a big windows, big area. But if you will look what you can save the lighting from energy side is just here. So this is the question and how to solve it. For residential building, that's okay. You can do small windows, but for office, and this is why we build. This is why we build the glazing buildings in Vilnius, in Brussels, and in Europe. It's wrong answer. Not because of that, because it's look nice, it's quickly to construct, it costs for user again to build the building, but from energy side, I'm afraid that after 20 or more years, we will look to these glazing buildings like we look now to the Soviet old buildings. It will be energy inefficient. So, just my opinion. So I'm coming to the end. So the thing is that we need to analyze building, and analyze before it is constructed. Before it is constructed, because then it is constructed. So to change something with the systems, it's quite complicated. After that, we're starting to think how much photovoltaics we need for this building, or something, another energy, or something, how to say it, but we need to start to think before the designing the building, and so then we will need to use less energy for that. So the conclusion is, and only one conclusion, that together we can make building efficient. Just we need to remember not only energy. I speak about energy because it's just in my head, energy. But another thing is very important, is the comfort, the ecology, like green building. The economy, okay, we can call it sustainable building. So, but all of us need to think, and now you see that architectures, they start to think and to speak about energy, and it's very, very good, very good. Everybody speaks about energy, and yeah. So let's make the building efficient before it is built. And thank you very much.